Hello guys, so today I'm going to do a Leetcode problem, the problem number 23, that is merge k-sorted lists. So here you are given merge k-sorted linked lists and return it as one sorted list, and you have to analyze and describe its complexity. So as input we are given here k-sorted list. In this case we have 3, and you have to build this output list that is in non-decreasing order. So this problem has been asked in Facebook, Amazon, Microsoft. So there are like two solutions to this problem. So the first one, which is naive one, you can create an array and you can sort this list, and once you're done after sorting, you can create a new linked list like this. So let's see the first solution. So if my list is going to be null or list dot length equals to 0, then I'm just going to return 0. And now I'm just going to create a list of integers, and let's call it collect is equal to new array list. And since we are going to follow the natural ordering of integers, so we don't need to give it any comparator. So will you loop through the list for lists, list node head. We grab the node of each of the heads from the list, and we say that while head is not equals to null, collect dot add dot val. Okay, and now once we are done, we need to create a new linked list. So for that, we'll just create a result. We'll create a dummy node at the beginning, and just let's insert it 0. And so you'll not be doing anything with this. And also let's create an iterator and point it to result. Okay, and now we'll loop through this list of integers. Okay, so once we have collected this list, we need to call sort by using the collections dot sort collect, and that should do the job. So now all the integers in my list, they are going to be sorted, and I just need to create a linked list out of it and give it out. So once it is done, I should do return result. Now I need to loop over this array using, we can use anything, so let's use a for loop for int I in collect can say that iterator dot next is equal to new list node by getting that value I, and then iterator is equal to iterator dot next. And now once we are done, so since this first node is a dummy one. I need to begin my linked list from the next one, so I'll just say result dot next, and that should be just enough. Let's see if it works. Okay, there are some errors. Okay, we cannot return 0. Somewhere we did some mistake. Oh, okay, so we are not incrementing the head. Head is equal to head dot next, and that is submissible. So in this case, since we put all the integers in an array, and now we are sorting it, so this takes in n log n operations, right? So if you want to do it faster or in better time complexity, so we can see that we have k list, right? So instead of sorting all the numbers together, we can use a merge sort technique. So in a usual merge sort logic, we have two arrays, but here you are given like k sorted list. So for that purpose, we can use a priority queue, and at the beginning we'll keep the heads in that queue, and the minimum that we are going to remove, the priority queue or the minimum heap, uh, at every step we'll remove the minimum value and increment our pointer to the next one. So that way we can just reduce the complexity, because every time you remove any element from the min heap, it takes order of k operation, log k operations. So in the end you will have your order of complexity n log k. So let's reset the solution. We'll just remove this stuff. And here we can create a priority queue of type list node. pq is equal to new, I can copy it again. So here we need to specify how are these list nodes are going to be compared. So for that we can give it a new comparator of type list node, and here you have to override a function called compare. You have to basically say how are you comparing it, and you can just give it list node A and list node B, and you can say that just return a dot val minus b dot val. So this comparator that we use, we can shorten this piece of code by using the lambda functions. So internally the lambda will always call this function. So I just wanted to show you how to reduce this step. So let's delete this, and we don't need this. So our lambda will take in, just like the int compare method, it will take into list nodes a and b, and what it is going to return is a dot val minus b dot val. So that's all we need. And in the beginning of this priority queue, we will first initially store all these heads here. So let's do that. So for list node head in list, so we are going to add it to the priority queue. So use that offer method. Just say that add. So however, in this case the head can also be a null, so we need to check it. If head is not equals to null, then only do this operation. Okay, for again storing the result, we need to create a dummy list. List node result is equal to new list node, and let's just give it any value. And also we need a iterator. And we just say that for the while our priority queue is not empty, current is equal to eq dot poll. And once we have got that value, so, and again this value cannot be a null, so we'll just say that iterator dot next is equal to new list node, or you can maybe use this current one, but let's create a new one. In this case, current dot val, and increment the pointer, the iterator. So that's done. So now in this case, since we removed one element from the priority queue, the size of the priority queue is going to be k minus 1. So now we need to add one based from the current. So in this example, if we have removed the element from the first one, so we need to add the next element from this linked list only. So we can do that by using the next element, and we say that if current dot next is not equals to null, then we add it to the priority queue dot offer current dot next. And finally, when we are done, we'll just remove or return the result dot next. I think that should do the job. And there is some error. The error is that it's not spelled properly. And let's see, get submitted. Okay, so it got submitted, and the runtime is now 4 milliseconds. So here the complexity of this code is actually order of n log k, because every time we are going to remove one element from the k size priority queue, and that takes log k operations, and the number of elements in total are n, so the final runtime complexity is n log k.